The aim of this research is to solve a local environmental problem through first, finding a significant local environmental topic. Second, conducting a site visit to the location of interest to observe environmental problems of that specific topic. Third, distributing a survey amongst the stakeholders that aims at introducing an optimal solution to a major problem observed. And finally, analyzing the surveys to extract relevant findings. The local environmental topic chosen is mangroves. In this presentation, there will be several stops. First, the introduction.
Mangroves are very significant to our ecosystem. They exist at the estuarine and deltaic areas between land and sea. They protect against extreme weather conditions, store between 10 to 15% of carbon in the atmosphere, protect the coastal from erosion, sea level rise, and are habitats to several marine species. They also provide visual, economic, and cultural benefits. Mangroves cover more than 152,000 kilometers around the world, limited to the area near the equator. Unfortunately, mangroves are disappearing at the rate of 2% per year.
In this presentation, we will look closer into the condition of the mangroves in the UAE, those of Abu Dhabi and Dubai. For Abu Dhabi, this research will look into the east of the Mangrove National Park highlighted in green and surrounded by several developments as shown, with a public promenade bordering it from the south. For Dubai, the research will look into the only mangrove site, the Ras Al Khor Wildlife Sanctuary, situated in the center of the urban area and surrounded by several developments too.
The mangroves of the UAE are comprised mainly of the extremely salt-tolerant grey mangroves called Avicennia marina, characterized by roots that curl up above soil to breathe. Moving on to stage 1, the site visit for Abu Dhabi. First issue observed is accessibility to the public, which has led to the exploitation of many boats to ensure maximum revenue and to the disturbance of wildlife. Second problem observed is oil and petrol spills. According to the researcher Connolly Hayes, oil spills can lead to the suffocation of the mangrove's root system. Third, seawalls. According to Paleologos, the construction of seawalls affects the natural land inclination, mangroves, and their seeding needs. Fourth, solid waste. In his research, Nimber mentions that aquatic and terrestrial organisms are negatively impacted by dumping trash into the mangrove site where non-biodegradable substance can hinder mangrove growth. Fifth issue observed is the water drainage pipe. In water, organisms break down the sewage, causing oxygen-depleted zones that become dead zones for the marine life. Dry, sharp mangroves are visible to certain parts of the park. Of the reasons for their death is extreme heat and rainfall shortage. Dead mangroves are emitting 8 times more methane gas than live trees. According to Paleologos, debris due to construction can impair the ability of mangrove seedlings to attach to the seabed. Construction projects can also increase the amount of zinc disposed into the waters. Sand from nearby construction is affecting substrate type and the wildlife there. More than 10 billion bacteria exist in the teaspoon of mud at mangroves forests.
Similar to Abu Dhabi site, there is nearby construction. According to Paleologos, coastal developments lead to erosion and pollution, causing changes in filtration, salinity level, and sedimentation of mangrove forests. Specifically for this site, the Dubai Creek Tower site represented using the red circle is at a close proximity to the mangroves area. Construction and excavation have started near the mangroves to expand the road highlighted in orange and shown in the figures on the right. Salinity is increasing due to groundwater being added from nearby construction sites such as Al Jadaf, the Creek Tower site, and Dubai Design District, along with the transformation of the nearby road. Salinity is shown through increased algal bloom and white salt powder on the sand. Samara et al. Says mangroves will work harder and utilize more of their energy to retain and maintain water balance due to increased salinity. Another issue is water level rise. Increased sea level will result in constant inundation of the mangroves, which will deprive them from oxygen and prevent seedlings from taking root after detaching from the mangrove tree. Increased water level has led to another problem, erosion of the northern bank, which is increasing and leaving the mangrove area exposed. Dubai Canal excavation added a different substrate not suitable for the mangroves because it is too sandy with several limestones as shown. Al-Mahdi et al. States that loamy clay silt is what mangroves need to grow because it stores water due to its porosity even at low tide. One more issue is mangrove habitat encroachment. Mangroves are growing closer to the urban areas. At the same time, they are limited from growing inside further into the wetland to preserve the special character of being a wading area for migrating birds. Similar to Abu Dhabi, Dubai mangroves suffer from solid waste. Physical damage from pollution due to abrasion, smothering, and clipping can degrade the marine habitats. And even though a pollution belt exists in Dubai, waste dumped by people from nearby accessible spaces fly due to wind or travel through water. Waste can alter the composition of sediments and can stress the mangroves, impairing their ability to sequester carbon. Similar to Abu Dhabi mangroves, dry mangroves have been noticed, and a die-off is occurring in the eastern side of the sanctuary, highlighted using the red rectangle. A research geologist attributes mangrove die-off to climate change and extreme weather. Wildlife biologist Fejkovsky says that when mangroves die, they become extremely hard like cement, leaving behind land that is not protected against flooding or erosion. It has been noticed across several years that flamingo birds are not nesting at the sanctuary, their numbers increasing because of migrating flamingos that have decided to stay due to the food supply. Unlike Abu Dhabi, the mangrove site at Dubai is not accessible by the public. For all the problems observed, different solutions were suggested. For example, for the seawalls, ecologically friendly seawalls made of reef balls and other organic materials can be used to replace rock walls. Or for inaccessibility, ecotourism can be encouraged for the sake of increasing awareness.
Moving on to stage 2. The major problem chosen is number 4, erosion at the northern bank in Dubai mangroves. The optimal solution will comprise of planting the mangroves in biodegradable pots that will be integrated into a system of smart planting. The biodegradable pot will ensure mangrove seedling growth. It will be made of marine-friendly biodegradable concrete. Slow-release fertilizer desk that ensures nutrients reach the seedling, a rack protector that opens up as a stem growth, and a hole to allow for marine life to coexist. Pot will be placed at the northern bank to solve the issues from erosion, habitat encroachment, dying mangroves, and unsuitable substrate. Biodegradable pots have been successfully used in USA. In Seaman Islands, pots got integrated with reef balls. In Shanghai, China, pots were put within Tetra pots. And in Australia, the proposal was to reuse the pots themselves. The second part of the solution has already been launched in 2015 in Malaysia, where mangrove growth rates has increased from 40 to 80%, and 2 years later in the Philippines, where after the initiative, 80% of the mangroves reached maturity. The solution involves sensors that are spread in the mangroves area to capture information on mangrove growth and the surrounding conditions such as humidity level, water level, soil moisture, and temperature. Information will be shared via an online dashboard for stakeholders to view.
Moving on to the survey and its analysis. The questionnaire was distributed via online means to over 600 participants comprising of 4 stakeholders: the local municipality, representatives from the agriculture sector, people living or working near mangroves, and the general public. The study sample comprised of 163 participants. The sample was divided as follows, with, for example, 16 responses from the mangrove neighbors. When asked about their knowledge on their local mangrove habitat, answers from those two stakeholders were dominated by poor knowledge, while responses from the agriculture sector and the municipality were dominated by good knowledge. Similarly, a study on a sample of 120 participants revealed that more effort has to be exerted to promote the local mangrove culture. When asked about reasons behind mangrove significance in the UAE, it is interesting to note that 50% of the mangrove neighbors chose visual appeal. That is probably due to their constant visual engagement with mangroves. However, 63% chose wildlife habitat, which is striking because, according to Dr. Fries, a biologist, research on this particular topic in the UAE is scarce. Regarding the question on threats facing the mangroves in UAE, 48% of all respondents identified urban sprawl as the most tenacious threat, followed by global warming. The first answer chosen may be attributed to the urban centralized location of mangroves in both Abu Dhabi and Dubai. It is interesting to note that although sea level rise is a pressing issue as mentioned by Dr. Amin, only representatives from the agriculture industry dominantly chose this option, represented by 60% of them.
The following question was different for each stakeholder depending on their aptitudes. 67% of the municipality employees are willing to allocate a budget for research, collaborating with different entities, and provide stick surveillance equally. 90% of agriculture sector representatives are willing to host mangrove seedling. 56 of the mangrove neighbors have expressed their willingness to participate in raising awareness about mangroves. Almost 60% of general public revealed their readiness to spread awareness and their promptness to help in planting mangroves. When asked about whether the optimal solution proposed would work, 96% of all the participants expressed their agreement. The graph shows the answer satisfied depending on the stakeholders.
And when asked about barriers for the solution, 62% selected funding dominated by the public, the agriculture sector, and the mangrove neighbors. This finding will encourage starting sponsorship programs to ensure funding for the solution. However, 67% of the municipality employees selected climate of the UAE and lack of trained staff, probably due to their direct involvement with those two options. And when asked about enablers, governmental incentive was selected by 62% of the total participants, while including mangrove visit as part of a tourist plan was favored by 60% of the agriculture sector and 75% of the municipality employees. Their selection can influence future accessibility to mangroves, especially in Dubai. It is interesting to note that 45% of the participants selected providing pots for free, which informs the need for allocating a low price for the pot.
Moving on to the conclusion. Funding came out as the most prevalent barrier while municipality employees expressed their willingness to allocate budget for research to help mangroves. Moreover, less than half of participants saw time and physical effort as a barrier, while the enabler mostly chosen was that of providing governmental incentive. With 96% of the respondents agreeing to the optimal solution, the step forward would be ensuring sponsorship along with extensive collaboration with the local municipality to design a prototype for the pot, place sensors on ground in mangrove wetlands, and starting the initiative.